Hey, what's going on, guys? Let's try this problem right here. Here we have a light ray that is traveling through this prism, and the question is asking to find out the angle that exit ray making, right? Angle that making with the normal. Now to find this one out, let's see what we can do. First we have this one of the angle is available, and if you notice, this is a z-shape. So when we have z-shape, the angle that makes is going to be equal, right? So that should be parallel, right? And here we have 45 degree. So we have this one. Now using this one we can find this one, because we need to know the angle that makes with the normal in order to use the Snell's law, right? So whenever we have this kind of problems, the main thing we try to use is Snell's law. So here we have 45 degree. So if this is 45 degree, and we know that the normal line that makes 90 degree with the surface, so we have 45 degree also already gone, so this also must be 45 degree. Now we have figured out this angle. Now using this information we can find out this angle. We can use the Snell's law. Snell's law states that n1 sin theta 1 is equivalent to n2 sin theta 2, right? Now since we are trying to find theta 2, let's rearrange this equation. Let's flip this equation around. So this is going to be n2 sin theta 2 is going to be equivalent to n1 sin theta 1, right? Now let's move everything except theta to the other side. So first sin theta 2 is going to be equivalent to n1 over n2 sin theta 1, right? And also we can move this sine to the other side. That's going to make this one sine inverse n1 over n2 sin theta 1, right? Now let's plug all the values. We have sine inverse, and n1 is air, so the index of refraction is 1. So 1 over, and the index of refraction of the prism is 1.5. So this is going to be 1.5 sine theta 1. The angle that is making with normal is 45 degrees, so this is going to be 45 degree, right? And if you plug all this value and calculate this one, you should get 28.1 degree, right? So we have this theta 2, the angle that is making with normal. Now how we can use this information to find this one, right? So here what you can do is, if you draw a line like this, if you continue this ray like this, we have 45, and this one is like this. And here if you notice, the surface that is actually this normal making with this ray is 45 degree. So here if this ray continues like this, the angle that making with this normal again inside also should be same, like this total angle should be again 45 degree, right? So if this is 45 degree, the angle of this one, this part right here, this one must be 45 minus theta 2, right? Because we know the total is 45 and this is included with theta 2. So if we subtract theta 2 from this one, that's going to give us this angle. So let's find that one out. So let's say that is theta, we can call some other name, right? Theta 5. Let's call this one theta 5. That's going to be equivalent to 45 minus theta 2, and we have found out theta 2 right here. So we can subtract that theta 2 from this one. So this is going to be 45 minus 28.1 degree, and if you calculate this one, you should get 16.9 degree. So this angle is really useful for us, because if you notice, we have a parallel line right here and it's making z-shape with this one. So if this one is 16.9 degree, this one also must be 16.9 degree. So we can say therefore theta 3 also 16.9 9 degree. Now this information is useful because we have the angle that is making with a normal. So if we have this angle that is making with a normal, we can find this angle using Snell's law. So again we are going to use the Snell's law. Snell's law is going to be what? N3, you can use N2 sine theta 3 because it's same material. To avoid confusion, I write N3 again, right? Because if we have N3 sine theta, N2 sine theta 3, sometimes it makes confusion. So we put N3 sine theta 3 and N4 sine theta 4. So here what we are trying to find is theta 4. Let's flip this around. So this is going to be N4 sine theta 4 is equivalent to N3 sine theta 3. Now we are trying to find theta 4. Let's separate everything else. So this is going to be sine theta 4 is going to be equivalent to N3 over N4 sine theta 3. Therefore theta 4 is going to be equivalent to sine inverse N3 over N4 sine theta 3, right? Now let's plug all the values. So this is equivalent to sine inverse N3. N3 is the material of index of refraction of prism, that is 1.5, over N4, that is this one, 1, and the angle theta 3 is 16.9 degree. So this is going to be sine 16.9 degree, and if you plug all this value in calculator, you should get 25.6 degree, right? So that's going to be the final answer. So the angle of theta 4 is 25.6 degree, and that's how we do this kind of problems. I hope this video was helpful to you. See you next time.